Hey, this is Ben, and I code your venture free.
I and Chris have found a startup project called Teleclaw last year. So what the hell is Teleclaw? Let me show you. This is a claw machine, and this is your mobile phone. Right now, you can control the claw machine behind me anytime and anywhere. So how can we do this? With a real-time streaming camera, you can control the claw machine remotely and see exactly what happened when you click the button. Awesome! So here's the problem. When I tell my friends about this idea, they always challenge me. Hey Ben, your virtual mobile application cannot completely mimic the gaming experience of a real claw machine. So what's the differences between these two? Let's check it out. Here's how the claw machines work. Insert a coin, control the joystick, drop the claw. Too fast, let's play again. Insert a coin, control the joystick, drop the claw. So what we're missing here is the hand feel of a control joystick. So let's go back to the cave and improve the gaming experience. My solution to the problem is to develop a handheld control that can play claw machines remotely. The purpose is to narrow down the gaming experience between a real joystick and a virtual one, just like the aircon control at your home. Here's the bill of materials: an ESP32 module, a 2-axis joystick, a LiPo battery, a 6mm tactile button switch, a 2.2 kΩ resistor. The reason that I choose the ESP32 module from Remote is simple. It comes with a battery solution by default that saves you much more time in power management issues. Step 1. Try to draft the schematic diagram for the circuit and test it out on the breadboard. Testing out the circuit before soldering the components together will save you much more time in the prototyping process. Bear in mind that although the label on the joystick is 5V, 3.3V is still an acceptable working voltage according to my experiment. Step 2. Write and upload the code to the ESP32 module. To keep it simple, I would like to use the Arduino IDE to program the logic. However, it is a little bit tricky to set up the development environment. So please follow the documentation on GitHub and download the USB driver from Silicon Labs. For some models of the ESP chips, long pressing the boot button when you upload the code. After setting up the environment, let's go through the business logic of our code base. Under this schematic design, the microcontroller will have 4 different inputs: the digital reading from the joystick switch and button switch, the analog reading from X-axis and Y-axis of the joystick. Based on these 4 inputs, we can program the microcontroller to trigger different HTTP requests. For instance, the analog readings from X-axis and Y-axis will be used as a command to control the claw. The HTTP request will send to our backend server via the IoT service provider in China. Finally, we definitely need a plastic case to house all the electronic components together. That's why I used the Fusion 360 to develop a basic 3D model and print it out with my old 3D printer. A small tip to make a great cup of instant coffee. Sometimes coffee powder and sugar do not mix very well together. Sugar is always sinking at the bottom of your cup. So my small advice is to mix the coffee powder and sugar first before pouring the hot water. There you go, tasty.
Okay, back to the project. After several failures and prototyping, finally, there is the 3D model that I really satisfy. The resolution of the printing is obviously not the best, but it is still good to go as a prototype. So everything is ready now, and let's put them all together. After a couple hours of hard working, voila, here's the first prototype, and let's play the claw machine together. Although it's a little bit laggy, this prototype is still a great attempt to be a proof of concept. If you are interested in this project, all the files and source code are linked in the description section below. There are definitely lots of improvements in the future. For example, I would like to design a custom PCB to tidy up the messy wires. Chris also suggested that cardboard will be a better alternative for those who don't have 3D printer.
So finally, I am not an expert in electronics. This is my first time to handle a project like this. I just want to share my thoughts and ideas with you guys. Also, consider to subscribe my YouTube channel for more prototyping and startup video like this. Thumbs up, stay tuned, and see you guys in the next episode. Meanwhile, let me play some crown game first.